So the area model of multiplication, or sometimes called the box method of multiplication, is a very important model that we use for multiplication, not just for grade 8, but we use this in higher level math and also in calculus. So it's really important to understand how this works, because this is how we look at some really more complex properties of multiplication. But we also just use it to do some basic calculations as well. So if we want to multiply 32 times 22, what we can do is write 32 as a length here, and we can break it apart, or what we call decompose it, into 30 plus 2. So what ends up happening is we conserve the whole length here, and 22 we can break it up into 20 plus 2. So we conserve the whole length this way. So we know that total area must be the same area as 32 times 22. But now, because we've broken up into simpler parts, this multiplication is much easier. So we do 3 times 2 and annex the 0, so we get 0, 0. So we can do 2 times 2 and annex 1, 0. We can do 3 times 2 and annex 1, 0. And 2 times 2 is 4. Then we can just add this all up. So 32 times 22 works out to be 704. And we know that this must be true because that length is conserved here. The length over here is conserved, so that the area must be conserved as well. So we can do this for 25 times 34. So I can maybe make this length equal to 30 plus 4. Okay, and then we'll make this into 20 plus 5. Okay, and again, we can just work out each individual area piece because there's much easier, simpler calculation. So we get 600, here is 80, 5 times 30 works out to be 150, 5 times 4 is 20. So adding this all up, we're going to get 100, 700, so it's going to be 850, okay, when we work that out. Okay, so this is a great way to work out area. We can also do division with this, because if we want to know these unknown lengths here along the vertical, we have some area and a length, so we can actually find out the other length through unmultiplying or dividing. So for example, we can say that 300 divided by 30 equals 10, because 10 times 30 equals 300. So we can write that in. And we know that the total area here is going to be 456. So we know that it looks like 140 must be split up between these two parts here. Okay, and so we can figure out, what these different pieces are, but by decomposing the multiplication or undoing the multiplication. So in this bottom right hand corner we get 16. The length is 8. The width here must be 2, because 2 times 8 equals 16, or we can say that 16 area divided by length gives me the other length of 2. So that must be 12 times 38, and when we work this out, okay, we get 80 here, 60 here, and just double check our calculation. Yeah, this should work out. 300 plus 80 plus 60 is 440, plus 16 is 456. So there's our area that we've conserved. Okay, so we can set up a box method for this more complex multiplication. Now there's lots of ways you can do it. If you know your multiples of 21, you could do it as 210 plus 8. If you don't like that, you can break it up into 3 parts if you like, as long as you conserve the length. So we can break it up into a length of 200, okay, plus 10 plus 8. Okay, so that whole length is going to be 218. Now we have 3 parts, but the area is still going to be conserved. And when we break this up, we can break this up into horizontally like this, into 20 plus 3. So then this makes the multiplication much easier, because now we just have 1-digit multiplication. 2 times 2 is 4. And we annex 3 zeros this time, so we get 4,000. Okay, 2 times 1 is 2. We annex 2 zeros. Okay, we get 16 and annex 1 0. Okay, 3 groups of 200 is 600. Okay, just check your zeros when you do this. 3 groups of 10 is 30. And 3 groups of 8 is 24. We can sum this all up. So I'm just gonna sum up the hundreds here. 800, 960, 990. So 1014 plus 4000 is 5014. Okay, so 23 times 218 we can work as 5014, and we can break this up into parts. Now some of you would do this naturally in mental mathematics, okay, doing this in your head, and most people when they do mental math, this is what they're doing. They're breaking it into easier parts to work with. Now there's different ways we can do this. Okay, some people might have kept this as 18 because they know they're multiples of 18. Some people would break it up into 3 parts like this. You can break it up into 4 parts if you like. Okay, but most people would probably keep it in terms of the hundreds, tens, and ones. Okay, so this one here, same thing, although we don't need to do hundreds, tens, and ones because there's no tens here, so we're just going to do 500 and 4, like that. And then for 75, we can do 70 plus 5. And again, some people like to use 25 because they know they're multiples of quarters. Okay, so they might want to do that, but for the most part, it's easiest to break it up into your hundreds, tens, and ones. So here we get 3 times 7 is 35, and we annexed 1, 2, 3 zeros. Okay, 500 times 5 is 2500. Okay, 7 times 40, or 4 times 70 is 280. 4 times 5 is 20. So here we're going to end up with 300, 2,800. So we get 37,800. Okay, as our sum. Okay, so that looks pretty good. So that's the total when we multiply those together.